Hey everyone, today I'll be introducing the concept of the function. So what a function is it's a mapping that sends each element in an input set, which we call the domain, to an element of an output set. Called the codomain. We write that like this. Say we have a function f sending inputs in D to outputs in C. It's written like this. F from D to C. And if F sends X to Y, we write F of X, where X is in this little parentheses, equals Y. Now it's important not to confuse F of X with some variable F times X, because that's a mistake I see a lot of students making. But what this means is we're sending X through the function F, and it's going to end up at Y. There's a very important distinction there. Now importantly, each input should go to only one output. Otherwise, the function's what we call not well defined. This should happen for every element of the codomain. And we say f of x is defined, or it equals something, if x is in the domain, so among the set of valid inputs. Now this will all make more sense with an explicit example. So let's say we have this example here, f from D to C, where D is, the stuff in this green box here, and C is the stuff in this blue box here. And we'll have our mapping be this. Now this function is not well defined because 1 goes to both 9 and 2. It is also not well defined because f of 48 goes nowhere, right? 48 does not get sent anywhere. So f from this domain doesn't work. So this is not a function. This mapping, however, is a function. Because every element in the domain goes to some output, and no element goes to two different outputs. Now notice that not every output has to be reached. And also, two inputs can go to the same output. Now, given this well-defined, valid function, we can say, if we want to find where 1 goes, we say f of 1 equals, and then we trace, let's see where 1 goes. F of 1 equals 9. And so we would know that this function maps 1 to 9. Okay, let's do a couple more examples. We have this example. And I'm going to draw a mapping. Now pause the video and try to answer this question on your own before I explain. Is this a function? What do you think? Okay, the correct answer is that this is not a function because 1 goes to two different values. It goes to 11 over 12, or 11 over 2, my bad. And it also goes to 6. It's also not a function because 128.3 doesn't have an output value. All right, let's do another one. Is this a function? Okay, the correct answer is yes, it is a function because no input value goes to two different values, and every input value has an output. Okay. Question number 2. Given this function, is g of minus 1 defined? If so, what is it? Pause the video and try to answer on your own. All right, the correct answer is that g of minus 1 is defined. And because g sends minus 1 to 11 over 2, we write g of minus 1 equals 11 over 2. All right, final question. Is g of 4 defined? And if so, what is it? All right, the correct answer here is that g of 4 is not defined because 4 is not in the domain. It's not in this little green box. So no, g of 4 is not defined. All right, final example. Here we've got two kind of wonky domains and codomains, which might seem odd at first, but the same concepts all apply. Your codomain and domain don't always have to be numbers. In fact, they can contain pretty much anything you want. Now, this function won't be very meaningful in a math sense in most contexts, but it's perfectly valid just from a definition standpoint. There's nothing wrong with it. So let's set up a mapping between them. I'm going to send dog to orange. We're going to have this here. I'm going to send lemon to Arizona State University. We're going to send 4 to triangle. We're going to send squirrel to the White House. All right, first question. Is this a well-defined function? All right, the correct answer is yes, it is a well-defined function because every input, once again, has an output, and it's a unique output. No input goes to two different ones. Okay. Is h of pentagon defined? And if so, what is it? Pause the video, try and figure it out yourself. All right, in this case, h of pentagon is not defined because pentagon is not in the input set. Final question. Is h of lemon defined? And you know the drill. What is it? All right, if you haven't figured it out yet, h of lemon is defined because lemon is in the domain. And because lemon is sent to Arizona State University, we have h of lemon equals Arizona State University. Kind of a fun example. All right. If you're watching this video for a college algebra class, you're not really going to need, in this class, sort of the full general definition of the function. Most of the time, your domain and range, or sorry, your domain and codomain will be numbers, or sets of numbers. So while it's useful to know that a function can be defined from any set to any other set, you'll mostly be focusing on functions that go from numbers to numbers. In higher math classes, you'll probably start encountering functions from, things that aren't numbers, but at this level, don't worry about the rest of them. Also, you won't be caring about the codomain that much. What you'll really be focusing on is something called range, which I'll explain in a later video. So keep that in mind as you sort of internalize the concepts in this video. All right, that's it for today. Thank you guys for watching.